Okay, it says 28 to 40. No. Last night we didn't do anything. I decided, you know what? Let's just do 16 to 40 evens. You got it? Someone's not writing that down and they're going to do the wrong thing tonight. Are you that person? Maybe. You can do them all. Definitely you can do them all. Like, don't let me stop you from doing that. Okay, so we're basically going to stick to day 17 notes today. I might go back for one or two examples from the day 16 notes yesterday, but we got all the way up through the product rule yesterday. Pretty good, right? All right, so we're going to start out today. I want to see if you remember that product rule. Remember how we said it? First times derivative of the second plus second times derivative of the first. See if you get, you don't have to simplify it once you get the derivative. I just want to see if you remember how to take the derivative of a product. That's an x cubed over, yeah, that's an x cubed over 4 minus 2. And this first set, yeah, this is just the fourth root of x and then minus 5x. Got it? Bless you. That's on camera. Thank you, Brian. I'm sneezing. Okay, once you plug everything into the product rule, you don't have to simplify. I just want to see if you can do it. Oh, that wasn't good. No, I'm connected. All right, wait a minute. Sorry. All right, we're back on the air. Okay, so who's volunteering? Did you say Nate? I thought she did. Anyone else wanna? Danielle, you wanna try? You can do it. Remember how it goes? First times derivative of the second times derivative of the first? Somebody can do it. All right, Riley, what do you think? Okay, I'll just leave it the fourth root of x. We'll make it that, okay? Beautiful. Nice. That's negative 3/4. Yeah, that's just a negative 3/4. Good job. Very nice job. Now, to do this, you really had to rewrite y as the product of x to the 1/4 minus 5x times, write that as 1/4 x cubed minus 2. Okay? So, apply the product rule. First times derivative of the second plus the second times derivative of the first. Take a look. See if you're not clear on any of those parts. A question on any of that? How about that derivative of the first? Are we okay with that? We had to bring down the fourth, so it's 1/4. You write x, and you subtract 1 from the exponent. 1/4 minus 4/4 is negative 3/4. Good? Yeah? You're not saying? Well, we'll see. We'll be doing some more practice here. Okay. Moving on. All right, we're not going to 16. We're going to get right back to the rules. Oops, this is still this. Sorry. All right, kids. You like rules? Every teenager likes rules. Do you guys like The Office?
Rule 17. Don't turn your back on bears, men you have wronged, or the dominant turkey during mating season. There are 40 rules all Schrute boys must learn before the age of 5. Learn your rules. You better learn your rules. If you don't, you'll be eaten in your sleep.
Just remember that. All right? That has nothing to do with anything, but just that rules are important, and you better learn them. All right? Now. Okay, so I'm going back to this. No, we're not. Okay, the first rule that we learned about was how to take the derivative of a constant. What would the derivative of 4 equal? 0, right? It's always 0. Constant functions are horizontal functions. Slope's always 0. Moving on. Second rule we learned about was the power rule. To take the derivative of x to a power, you bring the power down, you write x, you subtract 1 from the exponent. Try these two. Before you can apply the power rule, you have to rewrite them as x to a power. So you got to be comfortable with those negative and fractional exponents. Bless you. Rewrite them as x to a power first, then take the derivative. Who's ready to answer? You ready? Actually, I'm going to want one person just to tell me what the rewrite would be. Like not even taking the derivative, just how you would write each of these things. All right, the first one, 1 over x cubed is the same as x to negative 3. And what about that 4th root of x? X to the 1/4. Very good. I mean, you got to be able to do that first. And now who wants to actually tell me the derivative? Cameron, what do you got? Very good, because first you would bring down the negative 3, you write x, and you subtract 1. But when you rewrite it, you said it was negative 3 over x to the 4th. Okay? I want to try the second one? Yes, yeah. Well, tell me what it would be first. Okay. Now, what was the derivative going to be? Nice. And if you wanted to rewrite that without a negative or fractional exponent, you know what it would look like? Mm-hmm. Mm-hmm. 4th root of. Good. So 1 over 4 times the 4th root of x cubed. You like it? Power rule's good. Constant rule's great. Moving on. Third rule is the constant multiple rule. It says if you're trying to take the derivative of a constant times some function, just multiply the constant by the derivative. So do the rewrite first. Don't leave it 6 over x. Rewrite it. How can you rewrite 6 over x? Let's go with that. You know it. Oh, are you already getting the derivative? Just before we even take the derivative. 6? Mm-hmm. Good. Now, might as well go finish. Take the derivative now that you rewrote it. Nice. And when you rewrite that, what do we get? Negative 6 over x squared. How are we doing? All right. It's fun. I'll admit this is good stuff. All right. Then, the next rule says, if you want to take the derivative of a sum or a difference, just take the derivative of each term separately and then just add them up or subtract them, whatever you have. So here we are taking the derivative of a sum. So this rule is saying that we're allowed to take the derivatives of these two terms separately and then add them together. So you want to rewrite that first term before you take the derivative. I mean, the plus 5 can stay. How do you write 3 over x squared? 3x to the negative 2. Okay, now we can take the derivative of each separately. Add them together. Going up to tron it. What's the derivative of 3x to negative 2? Oh, Jess, you gone? Negative 6x. We got to subtract 1 from the old exponent. So, right, it'll be negative 3 when you subtract 1. Okay, and what's the derivative of 5? 0. Nice. Yeah. Oh, I went too far. Okay. So just rewriting 6 over x, we rewrite it as 6x to the negative 1. When you take the derivative, you multiply the exponent by the coefficient. That's the negative 6. You write x, and then you subtract 1 from the old exponent. Okay? Oh, what happened? I didn't finish it. All right, so for the final answer for e, exercise E, how can we rewrite it? Because right now we've got negative 6 x to the negative 3 plus 0. Jamie? Yep. Yep. That's it. I don't know why I decided to box that one, but I did. You guys see all right back there? There are a couple of seats. You know, there's one there, there's one there, if you ever want to move up. All right, then we get to the exciting part, what we were talking about yesterday. Product. Wait, that's not a product. Oh, we can make it a product. The product rule, before we even do it, I want you to say it in words. Remember that the derivative of a product equals first times the derivative of the second plus the second times the derivative of the first. Cool. So we have to first write this as a product. That's not a problem, right? Multiply by itself. Then go ahead and get the derivative. You don't have to well, you can clean it up. You'll see what I mean. I think we did one like this yesterday. Who wants to try putting in everything into the formula? So what's the first thing I should write down? The first thing I should write down. That's a hit. Come on. First term, right? The first factor. So we have the 3x squared minus x. So first, what do you have for the derivative of the second? 6x minus 1. You guys agree? Nice. Then what comes to the product rule? It's first derivative, second, plus. Don't forget that. Okay? Finish it up. Yep. Second. Good. All right, so that would be the derivative, but we can clean this up pretty easily. Right? Remember when this happened yesterday? What do you notice about these two terms here? They're the same. So if you have one of them and you add another one, you've got two of them. So we can just write this. I mean, we could multiply it all out, but we got better things to do. Bigger fish to fry. That's good enough. Did I just forget? Oh, yeah, thanks. Yeah, get sloppy here. Good. Thank you. Okay? Nope. Good. You know, sometimes you're just going to plug a value of x, in, and you might not feel like distributing. You just want to plug a 1 in for all the x's, or you want to plug in a 0. So it depends. All right. Are you guys ready for the last big rule? The quotient rule? Yeah, there's a little song. There's a little song for it. Okay, the last rule tells us how to take the derivative of a quotient. Okay, so we're taking the derivative of some function u over v. I'm going to put a little prime there. So what it says is, these are the words that are going to help us remember it. We're going to refer to the numerator as high. I'm going to write that in here. Let's refer to u, the function, the numerator, we'll call that high. This is up high, right? And we'll call the v down here low. This is how we're going to remember that this whole big mess is the derivative. We're going to remember the words low, meaning the denominator. Low, what do you think this d high means? Yeah, derivative of the numerator. You see that? So the words are low, that's your v, whatever's down here. D high, du dx is just the derivative of the numerator. D high. Less, what do you think that's referring to? The minus, right? Less. The high, that's just your numerator. dv dx, that's d low. So far we have low d high, derivative of the numerator, less, minus, high is the numerator, d low means derivative of the denominator. Draw the line, actually just draw the line, and down below, the denominator, v, squared will go. You know we're going to say this a few times. Now here's the thing. The one thing that kids do is they switch the parts up. They'll say high, d, low. No, no. In life, you start low, kids. And who is it who sang it best? Drake said started at the bottom, didn't he? And you have to start you have to start low. So don't ever switch them, because subtraction's not commutative. We don't do that, right? So it's going to be, so we got to say this a few times, right? It looks complicated, but it's not. All right, ready? Here we go. Low d high, less high d low, draw the line, and down below, the denominator squared will go. Again, low d high, less high d low, draw the line, and down below, the denominator squared will go. One more time. Low d high, less high d low, draw the line, and down below, the denominator squared will go. You got it? There is a song. Maybe I'll play it for you later, but let's just see how it works. It's so fun. Yeah, I got to play it because it's like stuck in my head. No, it's not that one. I've been singing it all day because I've been thinking about it. Okay. So you see, we're taking the derivative of a quotient. Right here. And it's, if the monomial was in the denominator, I could just divide it out of every term and it wouldn't be a quotient anymore. But you couldn't here. You have to use the quotient rule. So where do we start in life? Low. Yes, we do. Okay. So low is all that. So why don't you write all that down? X cubed minus 4x squared plus 4x minus 2. What should we write for d high? 2, right? D high means derivative of the numerator, so times 2. So we have low d high. What next? Less. So write down a minus, right? Low d high less high. What's the high? 2x. D low. Derivative of the denominator, so that's, can you guys read off what that would be? 3x squared minus 8x plus 4. Are we okay with that for the d low, the derivative of the denominator? What do I do next? Draw the line. And down below, denominator squared will go. Just write all that in. Good times, right? Good. Yeah. I'm not cleaning that up. Thanks. All right. But you got the basic idea? You understand how it works, though, that whole thing? All right, we're going to try another one. We're going to actually, oh, that's the, if anyone wants the music to the, I want to play it at home. I know, I didn't give it to you because I don't know. I just, no, because I don't know if they're going to play it. All right, now we're going to do some applications with all these rules, and we're going to keep practicing the rules as we go. I think that's the best way to do it. So the first application is writing the equation of a tangent line. And they want us to write the equation of the tangent line to this rational function at that point. To write the equation of a tangent line, you need the coordinates of a point. And they actually not only gave us the x, the 2, they plugged it in and got us the y1. So we have the x1 and the y1. So what's the only thing we need to write the equation of the tangent line? The slope. How do you get the slope of a tangent line? The derivative. So we're going to get the derivative using our rules. And then what are we going to plug into it? What number? 2, because we want to know the slope of the tangent line when x is 2. Right? So first things first, we're going to figure out what the derivative is. It's a quotient, so what should we use to get the derivative? Quotient rule, right? A little loady high. All right. Oh my gosh, where do we start? Low, start low. Okay. So low, we're going to write down the x squared plus 3. Low, d high. What's d high? 1. The derivative of the numerator is 1. So you don't have to write this, but just to show. Times 1. Low d high. Less. Minus. High. Right? What about d low? 2x. Good. Draw the line down below. The denominator squared will go. So you have your x squared plus 3 in there. It's got to be squared. How's that? Did I lose anyone with that? Okay, now, what number do we have to plug in there if we want to know 2? So we don't need to distribute. This is what I was trying to answer your question before. Like, a lot of times you just need to plug a number into it. So we're just going to do that. So everywhere we see an x, we're going to put a 2. And so what would be the value then of, oh, I want to show you something cool. When you want to plug a value in to dy dx, all you have to do is to indicate you're doing that, just draw a line. That means evaluate it at, and then you write x equals 2. So you're telling the world, okay, I've got dy dx, but now I'm going to evaluate it at x equals 2. Yeah. Great question. Hey, guys, in general, if I have, let's say, 4 times 3 minus 7 over 4, am I allowed to cancel that 4? And somebody's right. That's right. In order to cancel, okay, it has to be a factor of the whole numerator. You see, if you could pull the 4 out of both terms, all right, like if this instead, so you cannot do it here, but let's say this was 4 times 3 minus 8 over 4, okay? So I could pull the 4 out of this one too, and I could make it 4 times 3 minus 2 over 4. Then I could cancel. It's got to be, you can only cancel factors. And 4 is not a factor of the entire numerator. It's just a factor of this first term. It's got to be times the rest of the numerator before you can cancel it. Okay? So, yeah, that's a common mistake. So we're not going to be able to do that. But we'll just plug the 2 in. So what would x squared plus 7 equal? X squared plus 3. it's just so exciting. I can't control myself. Okay, so that would be 7. What would x minus 4 be if x was 2? Negative 2. And how about 2 times 2? All right, and we said x squared plus 3 was 7, so it's going to be 7 squared or 49. All right, so in the numerator, we've got 7 minus negative 2 times 4. 15. So we have 15 over 49. We are now ready to write the equation in point-slope form of this tangent line. Because we've got the point, right? That's your x1, y1. And we've got the slope. That's your derivative. Anyone up to it? Cameron, you want to. Try. Yeah. Okay, that's the y1. So we're going to have y minus y1. So it's going to be y plus 2 over 7. Good. Equals 15 over 49 times x minus 2. This is the equation of the tangent line to this curve at that point. You say you don't believe me? What you should do is on your calculator, later today, if you put this original function in y1 and you put the tangent line in y2, now in order to put that in your calculator, what would you have to do? Just subtract this 2/7, right? But if you put this tangent line in y2 and you put the function in y1 and graph it, you will see a of the tangent line. And just for your own self-gratification, so you believe you got the right one, you can graph it. And you'll see it. It's amazing. It's amazing. Let me think about that. That's one of the first, applications. We got all these rules, but now we can write equations of tangent lines to graphs anywhere we want. Let's try another. The second thing we want to be able to do is figure out where a graph has a horizontal tangent. Tell me when the tangent line's going to be horizontal. Right about here, right? People can't see that at home, but. And then when you get down over here. If you have a graph in front of you, you can just point, okay, it's horizontal there. But if you don't have a graph, all you have is an equation for the function. What could you do to, if the tangent's horizontal, what do you know about its slope? It's 0. So you could figure out where the slope, where the derivative is 0. Now, we're going to go through this. We're going to get the derivative, all right? And we're going to set it equal to 0. But when we get the derivative of a quotient, what's that derivative going to look like? And use a fraction. Now, you guys got to tell me. So we're going to have to figure out when a fraction is 0. Which of these 3 fractions is 0? The first one. A fraction is equal to 0 if only the numerator is 0. If the numerator only, if you have 0/3, you've got 0. Somebody gives you 0/2 of their estate, you know what? You've got 0. So 0 over any other number other than 0 is 0. If you divide by 0, that's undefined. And 0 over 0, nobody knows what it is. It's called indeterminate. So when you get the derivative and you're trying to figure out where it's 0, find out where the numerator is 0, and just make sure it doesn't make the denominator 0. So that's what we're going to do. So when you want to find horizontal tangents, you're going to get the derivative and set it equal to 0. But if that derivative is a fraction, it's going to be where the numerator only is 0. Let's do it. All right, so first step, I want to find horizontal tangents. What do I have to get first? What do I need to find? The derivative, right? Let's get the derivative. How are we going to get the derivative? Quotient rule. Okay, so the derivative low, write down your low. X squared plus 1. D high, what's the derivative of the numerator? 2x. Less, minus, high, x squared minus 3. D low, all over the denominator squared. So we want to find out where that's 0. So it's a fraction. So what do? Set the numerator equal to 0. So we'll just set the numerator equal to 0 and see if we can solve that. Numerator equal to 0. Now, some people might want to just multiply everything out. Some people might want to, there is a GCF here in those two terms. Do you see the GCF? The 2x. You just pull out the 2x from both terms, right? Might as well if it's here. And you want to solve an equation equal to 0. If you can factor it, that's a good way to go. It's not the only way, though. If you pull the 2x out of the first term, what do you have? X squared plus 1. If you pull it out of the second term, you got to be careful leaving the parentheses, right? The x squared minus 3. Okay, so the first factor is 2x. Can you clean up that second factor, like combine like terms? Manny? Yep. Yes, it would just be 4. Oh. So when is this going to equal 0? It's already all factored. What's the only value of x that's going to make 8x equal 0 or x equals 0? Now I do have to be careful. So I know that when x is 0, the numerator will be 0. I just want to make sure. Does it make the denominator 0? No, so it's good. So I will have a horizontal tangent when x equals 0. Now, what if you want to know the actual point, both coordinates of the point? You know the x-coordinate where you have a horizontal tangent is 0. How would you get the y? Plugging into what? The original. So might as well tell me. So if x is 0, plug in 0 for x, what's y? Negative 3. If you were to graph this function, you would see that it would have a horizontal tangent at the point 0, negative 3. Awesome. Yes. Oh, if you distributed this negative here, the x squareds would cancel, and then you'd be left with 1 plus 3, which is 4. Now, one thing that's going to look crazy to you, and they do it on the AP exam all the time, they want to see if you know your rules. But they give you values in a table. But if you know your rules, it's easy. We'll just do one of these. Suppose they tell you that f of x equals g of x times h of x. And they ask you to find f prime of 3. What you do is you just apply your rules. If you want f, first you got to find f prime of x. Now what rule would I have to use if f of x was g of x times h of x? How would I get the derivative? Product rule. So let's use the product rule. So we do first, that's your g of x. Yes. Oh, sorry. Anyone else? I must have pulled it off for another one. Oh, I just gave you the BC one. Oops. You can back. I am. Okay, so first, derivative of the second. If I call the second h of x, what should I call its derivative? H prime of x. Then what? Plus h of x times g prime of x. So you figure out the rule for f prime of x, And then to get f prime of 3, just plug in the 3 into your general rule. So it'd be g of 3 times h prime of 3 plus h of 3 times g prime of 3. See what we're doing? We're writing down the general rule. Now we filled in the 3. Then you just got to pick off the values from the little chart they give you. So what do I write for g of 3? 4. How about h prime of 3? I plus h of 3, 3. And that's negative 2. Yeah. So it'd be 4 pi minus 6. All right. So I don't get to the one thing, but I just want to fill in the little summary under the last thing, the second derivative. So if you want to write the equation of the tangent line to the graph y equals f of x at x equals a, equation of the tangent line would be y minus, how would you get y1? You plug a into what? To the original function, so it would be f of a. And then what about the slope? How would you get that? The derivative, and you plug a into the derivative, f prime of a times x minus a. To find where a function has a horizontal tangent, set what equal to what? Well, the derivative in general equal to 0, right? But if that derivative is a fraction, we know a fraction equals 0 when only the numerator equals 0. Very good. And then, so if they want you to find the derivative of a product or quotient of different functions at a particular value given a chart, first find, I'll just say it like the derivative, okay, using the appropriate rules. I'll just then call it f of x. Let's just say f prime of x. So the derivative. Then you can substitute values from the chart. So actually, I should have said first find the general derivative using the appropriate rules, then plug in the given value using, so I should say then plug in the given value. Given value. Yeah. Using values from the chart. Yeah, that was a little awkward. Sorry. All right, guys, so you're going to try the homework. The only ones you're not going to be able to do at the end if they ask you for the second derivative, we didn't get to that one. I think there are a couple at the end, maybe 38, 40, so don't have to bother doing that. Where did it go? Oh, here.